First thing we're going to look at is lines. A line has no endpoints. So point A there is on the line and infinite points are on the line and it never ends. A line segment then has two endpoints. So in this case the endpoints are A and B and it's denoted by the square brackets here. A ray has one endpoint and continues on through other points. This ray is denoted by AB. The square bracket where it begins, the B has no bracket because it keeps going through point B. If points are collinear, they're on the same line. So any two or more points that are on the same line are collinear. Parallel lines never meet. They have the same slope. Point of intersection is where two lines meet, and that point is called the point of intersection. Second thing we're going to look at is angles. Angle notation is denoted by this angle symbol, and where the angle is at, the letter is always in the middle of the three letters. An angle is formed where two lines intersect, so this is the angle ABC, or it could be written as BCA. A right angle is 90 degrees. The two lines where the angle is created are perpendicular to each other. An acute angle is an angle that's less than 90 degrees. An obtuse angle then is an angle that's greater than 90 degrees but less than 180 degrees. Finally, a reflex angle is greater than 180 but less than 360 degrees. A straight line is 180 degrees. So any straight line, the angle is 180 degrees. A full rotation then has an angle of 360 degrees, or a full circle 360. Vertically opposite angles are equal. So vertically opposite angles are created when there's a point of intersection, or two lines intersect, and the angle A here is equal to the angle C. Likewise, the angle D is equal to the angle B. Alternate angles are evident when there's two parallel lines, a line that cuts the two of them, or a transversal, and they make a Z shape, where if I look at the two yellow angles here, they make a Z shape where both points are inside the parallel lines, but they're on either side of the transversal. Other shapes like parallelograms may contain alternate angles if there is a diagonal drawn. Corresponding angles then create an F shape. You have to have two parallel lines and transversal again. If we look at the yellow angles again, they're the same. One is inside the parallel lines, one is outside. Both angles are on one side of the transversal. So you can see the corresponding, the two yellow, the two X's are equal, the two blue angles equal, and the two black angles equal as well. And finally, the sum of the interior angles add up to 180. So if you have two parallel lines and you have two angles inside the parallel lines on the same side of the transversal, so angle C plus angle D is equal to 180, and likewise angle A plus angle B is equal to 180 degrees. Next thing we're going to look at are triangles. Very importantly, all the angles in any triangle sum to 180 degrees. So angle X plus angle Y plus angle Z in this case equal to 180. The exterior angle is equal to the sum of the interior opposites. So the exterior angle is the angle outside the triangle, in this case D, is equal to the sum of the two interior opposites. So the angle D is equal to the angle B plus C. And the reason for that is the angle D plus A is equal to 180, and all the angles in the triangle are equal to 180. Therefore, this proves true. In an equilateral triangle, all the angles and all the sides are the same. Because all the angles are the same, all the angles are equal to 60 degrees. In an isosceles triangle then, two angles and two sides on them angles are the same. So if the two angles here are the same, then two of the sides opposite each other are the same as well. And finally, right angle triangles are triangles that contain a right angle. Quadrilaterals are four-sided figures, and they come in many different forms. So the first one is a square, and in a square all the sides are of the same length. The opposite sides are parallel to each other. Four angles are right angles, which are 90 degrees, and the diagonals, the two lines that join corner to corner, bisect each other, meaning this length is equal to this length, and this length is equal to this length. And in a square, they make four right angles. A rectangle, very similar to a square, given it has four right angles. Opposite sides are equal, but the diagonals bisect each other, but they don't make right angles in the diagonal. A parallelogram then has many properties, important properties. Opposite sides are parallel. Opposite sides are of equal length. The diagonals of a parallelogram bisect each other, meaning that this length here is equal to this length here, and the same on this side. And in the middle, the angles aren't all right angles, but you do create vertically opposite angles. So these two green angles are the same, and these two angles here are the same. Also, the angles in a parallelogram are equal. So this angle here in the corner is equal to this angle here, and this angle here is equal to this angle here. Finally, it's very important to remember that four angles in a quadrilateral in any four-sided figure always sum to 360 degrees when they have the exact same lengths of sides and angles. So there's exact same lengths of the sides and angles. Basically, they're an exact match of each other. To prove triangles are congruent, we must prove that either three of the sides are the same, which is denoted by SSS, two sides and one angle are the same, SAS, or two sides and one angle are the same. You also must give the geometric statement, which angles or sides are the same, followed by the reason why they are the same. And our conclusion is done by stating the type of congruency proved. In our first example, we're going to prove these triangles are congruent by side, side, side. And it's really important that you can do this correctly and that you can use the correct geometrical notation to do so. So it doesn't really matter where you start. I'm going to say, I know from this question, the length of the side AB, so the length, which is denoted by the modular symbol, AB is equal to the length DE. And that's your statement, and you must give a reason then afterwards. So the statement's given on the left, and the reason it's given. So again, if it's because it's denoted here in the example, it's given. Also, the length AC is equal to the length DF, and again, the reason for this one first is given as well. And finally, the length BC is equal to EF, and because it's given as well. Not always will all the reasons be given, but in this simple example they are. Geometrical statement on the left, reason on the right, and your conclusion then. Therefore, triangles ABC is congruent, or the congruent symbol is an equals to sign with another line parallel to it. It's congruent to triangle DEF, or you can just write it down in English, and the reason by S, 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 side, side, side. So what you could do as well, as you're going through it, you could say, okay, that's a side, and that's a side. In the second example, we're going to prove that it's congruent by SAS. So we know from looking at the question that the length of PR is the same as XZ, the length of QP is the same as YX, and the angles are given as well. Again, they won't always be given like this, but we just need to be able to write down the geometrical statement and the reason. So I'm going to start with the side. So the length of the side PR is equal to the length of the side XZ, and that's given. I know the angle is the same, so I'm going to go SAS, so that's the side. Then I'm going to say the angle is the same. So how you already know what the angle is the measure of the angle. So the modular symbol angle PRQ, or the blue angle there, is equal to the measure of the angle XZY, and the reason likewise is given. So that's the angle. And finally, you know that the last side is also the same. So the length of the side PQ is equal to the length of the side XY, and that's also given in this example. So that's by side. So therefore you can conclude, therefore the triangle PQR is congruent to triangle XYZ by side angle side, or SAS. In the next example, we're going to prove these triangles are congruent by angle side angle. So for this example, we know the two angles are the same and one side is the same. So the measure of the angle ZYX, we're going to go with the blue angles here first. You don't have to show the blue obviously, but just showing you here for the example, is equal to the measure of the angle CBA or ABC. And the reason for these are all given to you in the question. It's shown. We know as the sides are the same. YX, then YX is equal to the corresponding side BA. Again, it's given. It's my angle, my side. And finally, the last angle, the red angle, are the same as well. So the measure of the angle ZXY is equal to the measure of the angle CAB or BAC. Again, it doesn't matter. And the reason for that is given. That's your angle. So therefore, them two triangles are congruent. Triangle XYZ is congruent to triangle ABC by A angle side angle. And just looking at some more difficult examples here. So in the first three, I just wanted to look at how to write the notation correctly. But in all them examples, the information was always given. Whereas here we have some information given, but not all. Again, it doesn't matter if you prove angle, side, side, depending on the question. So in this case, the best thing to do would be to prove the most obvious one. And the most obvious one here, in this case, would be we have these two lengths. So we know they're the same. So I can start with a side. Again, it might only have one side depending on the question, but I know they're the same because it's given. So the length of BC is equal to the length of BD, and the reason for that is given. So there's nothing new there. Again, we're trying to prove that the two triangles are congruent, that this triangle is the same as this triangle, the exact same. So there's nothing else given in this question, and this is where we've used our geometrical skills from the start of the video to prove either another side is equal or another angle or two are equal. And the next one I see there is I know this angle has to be equal to this angle. And the reason, it's vertically opposite. So it's really important that you can spot them rules within the question. So that's the measure of the angle A, B, C is equal to the measure of the angle DBE, and this reason is it's vertically opposite. So it's not told you explicitly in the question, you must spot it. So again, if I go back, that's my side at the beginning. This is an angle, and I don't know. I know the angle, the length AB is the same, but I can't prove it. So I can't just write it down because it's not given to me either. So there must be another angle that are the same. And because AC and DE are parallel lines, then this angle here must be equal to this angle, or this angle is equal to this angle. You don't need to prove both of them are the same, only one of them. So I'm going to take these two angles that I've marked off in green. And I know they're the same, and they're only the same because they are alternate to each other. Because the lines are parallel to each other, they make a Z shape, they are alternate, or equal and alternate. So the measure of the angle CAB is equal to the measure of the angle DEB, and the reason it's alternate. So that's proving an angle is true. So I've proved two angles and one side is true. It doesn't matter which order they're, but therefore we can prove they're congruent. So triangles ABC and triangle BDE are congruent. Again, we can use a congruent symbol there if you want as well. By two angles inside is angle, side, angle. In the last example of congruency, we're going to prove that the triangle VWY, so this triangle here, is congruent to VZX, this triangle in here. And again, you can spot here, in this case, we're told two sides are the same, so I can go straight into proving or stating there. So the length of the line WV is equal to the length Vx, and that's given. I also know that the length, that's my side proven. I also know that the length Vy is equal to the length Vz, and that's also given. It's another side proven. And we don't know, or we can't say for sure that them two sides are the same, so I can't just let them equal. So it must be an angle. And the only angle you can prove are equal is this angle in here is equal to this angle in here. And the reason being, if you look at the full triangle VWX, then that's an isosceles triangle because the two outside sides, them two sides are the same, meaning that the two angles on them are also the same. So I can prove that them two angles are the same because they're opposite sides in an isosceles triangle or isosceles triangle. So the measure of the angle VWY is equal to the measure of the angle VXZ, and the angles opposite in isosceles triangle. And therefore, that's an angle proven. Therefore, triangle VWY is congruent to triangle VZX by two sides in angle, so it's going to be SAS. The theorem of Pythagoras, or Pythagoras' theorem, is used when you're given the length of two sides in a right angle triangle and asked to find the length of the third side. So the formula, which is on page 16 in the log tables, c squared is equal to a squared plus b squared, where c is the length of the side opposite the right angle. So this formula, as you can see here, on page 16 in the log tables, at the bottom of the screen here, where C is the side opposite the right angle. So it's really important that you label the side C as the one opposite the right angle whenever you're using Pythagoras' theorem, and you go from there. So if we look at our triangle here, when you're labeling it, you measure the side opposite the right angle, or you label that as C, and it doesn't matter which side you label the other two sides. So I'm going to call that A and B. Again, it doesn't matter which you call the other two sides. That is the side C. In this example, the first thing I'm going to do is, I know I'm given two sides in a right angle triangle. I'm asked to find the length of the third side. So the first thing I would do is write down your formula. C squared is equal to A squared plus B squared. Then label the sides correctly. The side C is one opposite the right angle, and again, it doesn't matter which side you call A and B. So C is the hypotenuse, the longest side. Then you fill in with your formula. So instead of C, I'm going to put X. Use brackets always when you're subbing in. X squared is equal to 12 squared plus B squared, which is 5 squared. Again, just take your time with this. That becomes X squared is equal to, you can use your calculator there as well, 144 plus 5 squared is 25. So X squared is equal to 169. To get X on its own, you get the square root of both sides. Again, you don't have to show this if you don't want to. So X is equal to square root of 169. And just to show you that in the calculator, so to get that in the calculator, square root of 169, which is 30. So the angle is equal to, the length of the side X, in this case, is equal to 30. Same for the second example. I'm given two sides in a right angle triangle. I'm asked to find the length of the third side. I write down Pythagoras' theorem. Again, you label C as the longest side, the side opposite the right angle. So this time C is 5, X is A, and that side is 4 is B. Again, doesn't matter, A and B. Submit your formula. So 5 squared is equal to X to B squared plus 4 squared. 5 squared is 25 is equal to X squared plus 4 squared is 16. Keep all the unknowns on one side of the equation. So I'm going to keep the x's on the right hand side, and you can bring them over to the other side if you want. When the 16 comes across, it becomes minus. So 25 minus 16 is equal to x squared. 9 is equal to x squared. So the square root of 9, you end up getting x is equal to 3. Get the square root of both sides. In the third example, we're solving for x. So I can write down my Pythagoras theorem. C squared is equal to a squared plus b squared. Label your sides. The side opposite the right angle is 7. That's still in C. And again, A and B don't matter. Putting them into the formula, put 7 squared is equal to 4 squared plus x squared. So 49 is equal to 16 plus x squared. Bring over the 16 to get x squared on its own. So 49 minus 16 is equal to x squared. 49 minus 16 is 33 is equal to x squared. And if it doesn't go up as a whole number, you can get x on its own here. So get the square root of both sides to get x. So x becomes, so get the square root of both sides to get x. The square root of 33. So square root of 33. Again, it doesn't change. If it's a decimal place, you can press that button. But if it doesn't, just leave it in third form. So that's okay. So x is equal to just root 33. And finally, when you're given a triangle that contains more than one triangle, just do one at a time. So what I would do here is you're solving for x and y. It doesn't matter which one you solve for first. So what I'm going to do is I'm going to take this triangle here first. You could draw it out separately if you wanted to. So if I'm going to label, what I'm going to do here is I'm going to just use this triangle. I'm going to put everything in yellow here first. So I'm going to length the side opposite right angle is C. I'm going to call that A, and I'm going to call that length B. So using my Pythagoras theorem, I can end up with x squared is equal to 10 squared plus 12 squared. Again, use your brackets, good habit to use. So x squared is equal to 100 plus 144. X squared is equal to 244. So you get the square root of 244, the square root of both sides. So square root of 244, which is in its nicest third form, 2 root 61. So 2 square root 61. Again, don't give in decimal places unless you're asked. So the next one then, I'm going to just do in red. Again, you could draw it out separately if you want. But in this case, my side opposite my right angle is 14. So I'm going to call that C. 10 can still be A. And Y is going to be B. So solving there, using Pythagoras theorem, C squared, so 14 to B squared is equal to A squared, which is 10 squared, plus B squared in this case, which is Y squared. 14 squared is 196 is equal to 100 plus Y squared. We want the Y squared and so on, so the minus 100 from both sides, to bring over the 100, change the sign. So 196 minus 100 is equal to Y squared. So 96 is equal to Y squared. Get the square root of both sides to get Y on its own. So the square root of 96 in your calculator comes 4 root 6 in its insert form. So Y is equal to 4 root 6.